Hi everyone, today we're going to learn about common factoring. To factor something is to do the opposite of the distributive property. Common factoring can be compared to looking at an expression that has had the distributive property applied to it and then imagining what it would look like before it was expanded. So if we had an answer from a distributive property question of 3x squared minus 9x plus 12, we could factor that by putting a 3 outside the brackets and then thinking about what would need to be inside the brackets so that when it was multiplied by 3, we would get the original expression. In this case, it would be x squared minus 3x plus 4. We can check our answer by doing the distributive property to it. So 3 times x squared would give us 3x squared, and 3 times minus 3x would give us minus 9x, and 3 times 4 would give us 12. And this matches our original expression, so we know we've done the factoring correctly. Let's look at some examples and consider how we could take some expanded or standard form equations and move them back into factored form. In order to factor an expression, we need to look at the coefficients of each terms and find out the greatest common factor of all the coefficients. So in the case of 2x squared minus 8x minus 40, we can look at each one of the coefficients and consider what factors they might have. 2, for instance, would have 1 and 2 as factors. There's no other factors that multiply to give us 2. 8 would have factors of 1 and 8, and 2 and 4. 40 would have factors of 1 and 40, 2 and 20, 4 and 10, and 5 and 8. And when we look across all three coefficients, we can see that they all have a factor of 2. This is what we will factor out of our expression. So we'll continue to write y equals. We'll put our 2 out in front of the brackets, and then inside the brackets we'll put whatever would happen to the original expression if we divided it by 2. So 2x squared divided by 2 would give us x squared. Negative 8x divided by 2 would give us negative 4x. And negative 40 divided by 2 would give us negative 20. Remember that we can verify our answer by using the distributive property to see if we get the original expression. 2 times x squared would give us 2x squared. 2 times negative 4x would give us negative 8x. And 2 times negative 20 would give us negative 40. So we know we've done this correctly. In our second example, we have the coefficients of 3, 6, and 30. Notice that I'm ignoring whether they're positive or negative because the greatest common factors are really irrelevant in terms of whether it's a positive or a negative. The factors of 3 or of negative 3 would involve a 1 and a 3. The factors of 6 or negative 6 would involve a 1 multiplied by a 6 or a 2 multiplied by a 3. And for 30 or negative 30, we would have 1 and 30, 2 and 15, 3 and 10, and 5 and 6. When we look across all the factors, we can see that 3 is common among all three of the coefficients. Because our original expanded form expression has a negative 3 as its first coefficient, we will factor out a negative 3 from the entire expression. This will mean we'll have negative 3 outside the brackets, and then inside the brackets we'll have x squared plus 2x plus 10. We can verify this once again by multiplying the negative 3 into the set of brackets. If we were to do this, we would have negative 3x squared minus 6x minus 30. Since this matches our original expanded form, we know we are correct. Now let's find the common factors between 12, 20, and 40. For 12, the factors, or numbers that can be divided into 12, are 1 times 12, 2 times 6, or 3 times 4. For 20, the factors are 1 times 20, 2 times 10, 4 times 5. And for the factors of 40, we have 1 times 40, 2 times 20, 4 times 10, or 5 times 8. If we look across all of these coefficients, we can see that there's a common factor of 4 within each of them. So we'll factor out a 4 from our expression, and then inside the brackets, we will have left 3x squared plus 5x minus 10. In our next example, we will find the factors of 6, 18, and 24. The factors of 6 are 1 times 6, or 2 times 3. The factors of 18 are 1 times 18, 2 times 9, or 3 times 6. And the factors of 24 are 1 times 24, 2 times 12, 3 times 8, or 4 times 6. In this case, we can see that 6 is a common factor for all of the coefficients. Since the original expression has a negative 6 as its coefficient of the x squared, this is what we're going to factor out. So we'll have negative 6 out front of the brackets, and inside the brackets we'll have the result if our original expression were divided by negative 6. This would be x squared minus 3x plus 4. The next example has coefficients of 8, 16, and 36. So we'll determine the factors for each of these coefficients. 8 would be 1 times 8, or 2 times 4. 16 would be 1 times 16, or 2 times 8, or 4 times 4. 36 will have factors of 1 times 36, 2 times 18, 3 times 12, 4 times 9, or 6 times 6. Looking across all of these coefficients and their greatest common factors, we can see that the greatest common factor will be 4. So we will factor out a 4 in front of our brackets, and then inside the brackets we'll be left with 2x squared minus 4x minus 9. In our final example, we will need to find the greatest common factors for the coefficients of 9, 27, and 81. For 9, it'll be 1 times 9, or 3 times 3. 27 has the factors 1 times 27, or 3 times 9. And 81 has the factors of 1 times 81, 3 times 27, or 9 times 9. Across all the coefficients, we can find a greatest common factor of 9. Again, in the original expression, the x squared term has a negative coefficient, so we will factor out a negative number. In this case, it'll be negative 9. Left inside the brackets will be x squared minus 3x minus 9. You can see as you're doing greatest common factoring that the things you're going to need to be aware of are what are the factors of the coefficients for each term within the expression, as well as you'll have to pay particular attention to the positives and negatives. Remember that you can always verify your answer by multiplying what is in front of your brackets by everything inside the brackets to see if it matches up with your original expanded form expression.